All right, so today we'll take a look at text processing and regular expressions. This is kind of like the magic. Well, not really magic. Well, I thought Arvest was really cool, and dplyr and tidyr. I think these are all really cool things. This is, in my opinion, homework 3 is a fun one, but I thought tic-tac-toe was fun also. So, but okay. But I think homework 3. I'm hoping when you guys work through it, you'll also get a sense of satisfaction as you are able to scrape the web and pull things out, okay? And anytime you are pulling stuff off of the web, you're going to have to be able to extract things out of the text, okay? Unless the web has a nice API where they, export things in nice little formats and JSON and whatever like that, if you have access to that, excellent, all right? Use that. But if you don't, you're going to have to kind of use the browser and like your web browser and scrape things, and Arvest allows you to do things like that. And then text processing is good for that. I do have to say this, and I regret teaching you SuperAssignment, okay? So I've seen people talking about SuperAssignment, and so SuperAssignment is one of those things that you should generally avoid using, especially if it's trying to change things in the global environment, okay? So, if you used it for the tic-tac-toe assignment, that's fine. I'm not going to dock you any points for using SuperAssignment, but I want to tell you now, don't get in the habit of using it, okay? So, regular old functions, they keep everything in that execution environment. When you run the function, stuff goes into the execution environment, and when the function finishes, that execution environment disappears, okay? And that way, you only have to keep track of the stuff you give the function via the arguments and the one thing that it returns. And maybe you need to keep track of several things, and so you return a list. That's fine, okay? If you start using SuperAssignment and start messing around with things in the global environment, now when you run a function, you have to keep track of everything that could possibly affect what's going on in the global environment, okay? So now you're not just looking at the things in your arguments, but now if you're referencing something in your function, now you have to worry about what could be affecting things in the global environment. And so it just complicates things. And so when you use, like, in the most simplest cases, sure, SuperAssignment could be a quick shortcut to do what you want it to do. But as soon as you add complexity, and as soon as you experience a bug, trying to debug with a SuperAssignment somewhere out there, it gets a lot more complicated, because now you have 20 things to keep track of rather than just 3 or 4 things to keep track of. So anyway. So if you were trying to deal with the update function, so this is the probably the simplest version of the update function that doesn't do any kind of error checking. This would be bad form, where you have the state of your tic-tac-toe board like this, and then you are updating the state using SuperAssignment, and you would run the function like this, okay? This would technically work, but this I would say is bad form, okay? The proper and here I made a mistake. This is only supposed to be regular assignment. I apologize. So the good form here, the good form is to have the state, and then you update the state. This is regular assignment. I gotta fix that here, especially if I'm trying to tell you how to have good form. Okay, and so in this case, you update the state that exists in okay, and so here you update the state that exists only in the execution environment. Okay, it doesn't affect what's out here. So this only updates the state that's in the execution environment, and then at the end of the function you return the state. And then if you want to update the state in the global environment, you do it in a global environment command saying update the state, and when it returns that state, you store that into the state variable in the global environment, okay? And this way, if something goes wrong, you can fix it in here, or if something is going wrong in the global environment, you can fix it out here, okay? So this keeps it separate. Whereas over here, you just run the function and it changes something in the global environment. And so this is, so again, you know, when you're trying to debug and you're reading stuff like this and you just see update, it's hard to see what this is doing. It's hard to see where this is making the changes, okay? Whereas when you're trying to debug something like this, it is very clear that when you run this function, the thing that it's changing is the state in the global environment, okay? Does that distinction make sense? Yes, question?
You said something earlier, I just want to know if it's a bad form to return a list.
No, returning a list is good form, okay? So when you, if you have like 10 things to keep track of, you put them in a list, and then if it, and it's like, maybe the list is, there's things you want to keep track of. You want to keep track of the state, you want to keep track of, you know, who is playing X and who is playing O, or like, you know, these are things you might want to be keeping track of. Then you would say state, and then you do update, you'd run the thing, and because it's returning a list, at the end of this you can just put $state, or $who is X, $who is O, okay? And you can do that because running this thing will be returning a list, and then you can then take that list and do the whatever that is, okay? Does that make sense? So returning a list, good form, okay? If you need to keep track of multiple things, that's how you do it. Okay, so then you know, why do I bother covering super assignment? That there are useful cases. First of all, it's important when we're talking about scoping and environments and things like that. It is an important concept there, okay? We will cover reference classes in our course, and it's a useful thing to be used as part of the methods. And then in functional programming, which we are not really going to get into this course, you know, you are using functions to create other functions, and we had a very brief example of that, but there might be cases where you want to have kind of like two levels of parameters. You have the parameters for the functions that you are creating itself, and in that case it could be useful to adjust things in the kind of the higher scope, okay? But still in that case you are not using super assignment to mess with things in the global environment, okay? So in general, very bad idea to use super assignment to change things in the global environment, okay? Except in the most simplest of forms, and you just need a shortcut. But otherwise, return a list and then keep track of the things in the list, yeah. Okay? And then Hadley Wickham has some thoughts on super assignment. You can check out that link if you want to read it. Okay, so now we can talk about regular expressions. We'll use the package stringer. So if you haven't done so already, in R, install stringer, and load that up, library stringer. And then if you want kind of more details on some of these regular expressions, you can ask for help here. You can also read this vignette on stringer. There's also some good tutorials online covering regular expressions. I'll cover some of the basics here, okay? So regular expressions are a way to search for things, right? So I'm sure in when you've been writing an essay or something, in Microsoft Word you might have used find and replace, right? Like you realized something, so you do like Control F and you find things, and then maybe you replace that word with something else, okay? Or something like that. So basically, you want to be searching through text. Now, there might have been a time during your essay where you wish you could change different forms of a word, right? Like, you know, you want to search for the word run, but you also want to search for running and runners and I don't know, stuff like that, okay? Well, regular expressions, well, as far as natural language, it's a little bit more complex, but regular expressions allow you to start searching for, you know, slight variations on things, or even more complex variations on things, and that's all handled via during the idea of creating a pattern, okay? And so we have some basic functions. We've got string detect, which basically you give it some text in a string, and then you say, you know, do you find the pattern in this string? And it'll return true or false if it finds it or not. Locate will tell you where in the string it finds it. Extract will pull that string out. Match is similar to extract. It pulls the thing out, except you can give it what's called capture groups, which really make string or regular expression functions a bit of power, in my opinion. And then split, you can kind of like split up a string into different things, okay? And then a lot of times we have like string detect all, string match all, string extract all, which will work with, you know, if it finds multiple things of these things. Otherwise, it'll kind of just find the, you know, it'll find the first thing it finds and return that thing. Okay, so so here's a little comic from XKCD, and it says, you know, whenever I learn a new skill, I can concoct elaborate. All right, you guys can read this, and right. Okay. Well, I thought it was cute. So as far as regular expressions go, because it allows you to do stuff like this, right? You know, we have to search through a bunch of emails looking for something formatted like an address, right? And so to do this by hand, it could be hard. And so regular expressions could help you out. Okay, so there's just simple old matching, and this is kind of what in Word you do Control F to do the find. This is what simple matching is. You type in the text. I want to find the word quick, and here we've got a vector of words, and it will say, oh, I found quick in the second element of the vector, and I didn't find it anywhere else. Okay. Or here, you know, find the letter O, and it will say, oh, I found it in brown, and I found it in fox, and I found it in over, and I found it in dog. Okay, and I didn't find the letter O elsewhere. Okay. Or find the string ROW, and it will say I found it in brown. Okay. And there you go. So that's just simple old matching. You just type in the word that you're looking for, and it'll look for it. Okay. It is case sensitive. So if you typed in capital R O W, it's not going to work. Okay, it's case sensitive. Yeah, question.
How do you break like a paragraph up into like small little words like that?
Oh, you string split on the space. So if you have like a one line, you do like a string split, and then you say like the separator will be space. Okay, this is where regular expressions get their power in these meta characters. These are your special characters, okay? And anytime you use one of these, it's going to take on a special meaning. And if you want to match the literal one of these, like if you are actually looking for the value square bracket, you have to escape it, okay? And this is, you know, this is one thing, like in Google, you're like trying to find things in code, and you're like, how do I, you know, what does this operator mean? And Google always kind of just strips out these operators, and I don't know if you can do literal matching in Google as far as character things go. But anyway, so for example, let's say we have this string ABC square bracket DEF, and if you search for square bracket, it's going to say, you know, you're using this special character, and when you use a square bracket, you've got to also have a closing square bracket generally in regular expression. So it kicks back an error here. So if we want to match the actual square bracket, we have to escape it using the backslash. Okay? But because the backslash itself is a special character, you have to do the double backslash. Okay? So you have to say, I want you to look for the square bracket, and you have to do double backslash square bracket, and this will look just for the literal square bracket character. Okay? And then it will return true here. Yeah, question?
If it was separated by another backslash, would you just do three backslashes?
Oh, if I had... So if you're saying my string is ABC slash this DEF, okay.
Yeah, just like
Oops.
just one backslash. So
Oh, it doesn't even like me to, okay. Isn't unrecognized character in the, well, see, now I'm not even sure what's happening here. It won't let me do a single, it's thinking I'm trying to escape this. Let me see. So you kind of have to do double backslashes whenever you put them in strings, otherwise it gets angry here. So let me, and we'll say we want to search for the square bracket, and then I think I have to do double backslash, double backslash. Okay. So this double backslash matches this single backslash, and this double backslash matches that single backslash. Okay. So I know it's kind of crazy, but here I think if I do extract, yeah, it pulls that out. Or if I did this, ooh. It doesn't even like that. Okay. So yeah, you just have to keep in mind, you almost, when you're putting things in, you almost never use the single backslash itself. You're almost always going to be using double backslash, and it's a little bit funny. You'll get used to it. Okay, so here, yeah, we're doing it that way. Okay, here we have what we call anchors. And so this says, I want you to find the thing, but only if it's at the start of the string, or only if it's at the end of the string. We also have if it's a word boundary or non-word boundary, and I'll show you what those mean, okay? So here it says, here we have just one string. The quick brown fox jumps over the lazy dog. And here we want to find, we're going to replace if it finds the word the, but it only will match if it's at the start of the string, and it will replace it with a dash, okay? And so here it finds it because the is at the start of the string. If I say start of the string dog, it doesn't find any match, okay? Because there is dog, but it's not at the start of the string. This is find the word the, but at the end of the string, and there's going to be no match. And here is dog at the end of the string, and it finds it, and there is a match. Okay? And so it'll recognize whether it's at the front or end of the string. Slash A is the same thing as the caret, meaning start of the string. Okay, slash A means quick has to be at the beginning and there's no match, or at the very end with slash Z. So these match or don't match accordingly. Slash B means word boundary. Okay, so here we're finding jumps, and it means there has to be a word boundary, which, whoops, basically means there's a space before the word jumps and a space after the word jumps, okay? Or if it's not a space, it's like a new line or something to indicate that this is the end of a word, okay? And so here it finds the word jumps, okay, and replaces it. But over here, we have the word jump, and it will find the slash B, the word boundary for jump, okay, but it doesn't find the boundary at the end of P, so there's no match. There's no match here. Okay. Capital B slash capital B is a non-word boundary. So this means you can't have a space over here and you can't have a space over here. So if it matches the UMP in the middle of jumps. Okay. Whereas if I put capital B for J, because this is now a word boundary, it's not going to match. Okay, so you have word boundaries and non-word boundaries, or start or end of the string. Okay, we have special character classes. Okay, slash little s is white space, and so that is either could be new line, a space, or a whole bunch of space together. That's white space, okay? Slash S is non-white space. This is capital S, okay? So little means you want the thing, and then capital D will be like not the thing, okay? So slash little d will be a digit, capital D will be non-digit, okay? Oh, and this didn't make a new line, but so, and slash little w is a word character, meaning any of the letters capital A through Z, little a through Z, or 0 through 9, or an underscore counts as a word, and then capital W will be not words, so any things that are not these characters. Okay. You can also give ranges of characters. So we have dot, which will be any character except the new line character. Here you are giving it square bracket ABC. And this means match on, this represents just one character, and that one character has to be an A or a B or a C. Okay? It's not going to match the letters A, B, C together. It's just going to match one character, and that one character has to be either an A, B, or C. Okay? And this again is match one character that is not an A, B, or C. Okay? You put a little a caret here, meaning not anything inside this range. Okay? You can also give it a range like A through Q, or capital A through Q, or a digit O through 7. Okay? And it kind of understands the way our alphabets are set up. Okay, so here I've got a vector. So I've got the fox, the lazy dog, theater, and Prometheus. Okay, and so here we're going to try to find text the, T-H-E, lowercase t-h-e. It's not going to match here because we've got a capital T. Okay, of course it's not going to match fox. It matches the here. It matches theater, and it will also match the and Prometheus. Okay, and so that's what string match. It finds these matches here. If I change it to bracket THE, this will search just for one letter, and it has to match either the T, H, or E, and it will match the first thing that it finds. So in this case, it will match the H in the. Okay, nothing in fox. It'll match the T in this the. It'll match the T in theater. And as far as Prometheus goes, it'll match this E right here. Okay? And so that's what it's saying. Does that make sense? So it's just saying it's got to match either the T, the H, or the E, and give me back the first thing that it has found there. You can give regular expressions quantifiers. Okay, we will attach these to literals, meaning the word the or whatever it might be. Okay, you can give them to character classes, ranges, or groups to match repeats. Okay, so this will say match 0 or more, the star. The plus means match one of those things or more. A question mark means match 0 or 1. And then curly brace and number will say match exactly 3 of these things. Curly brace with a number and a comma and nothing after that is match 3 or more, and 3, 5 would be match 3, 4, or 5 of those things. Okay, so you can give it something like this. So here I'm using the theater, Prometheus, TZZE, and THHZZ. Okay, so here it says match, and we're going to search for either the T, H, or E, and we want to find exactly 2 of those things. Okay, so I put curly brace 2, so this means find 2 of these things, and so here it goes to this thing and it will match the H and the E. Okay, and they're together. Over here it matches the T and the H. Theater, it also matches the T and the H. Remember, it's returning the first thing that it finds that matches the criteria. Over here it finds ET and Prometheus and returns that. Okay. In this word, okay, it finds no match because it finds the T, but then it's followed up by Z's. Okay, and then it finds the E, but there's nothing after that. So there's no match here because there's not T, H, or E and 2 of them together. So there's no match here. Up over here, it sees the T, but then it's followed by a Z, so it's not going to match there. It finds the H and the H, which counts as two things from this thing, and so it matches that. Okay. Yes, question.
Shouldn't the last one return a T and an H because you find the T first and then it skips over the Z?
It doesn't skip over the Z's. What this means is that you've got to find T, H, or E, and you've got to find two of them, but they've got to be together. Okay? Yes?
So like for the word
Tooth.
it wouldn't catch the first T,
It-
it would catch the N.
Yeah, if it was tooth, it would not catch the first T, it would catch the TH at the end. Okay? That would kind of be like this example here. All right? I can also, let me, what would happen if I did 2 comma? Where did it go? So here's my text, okay? And then instead of, so this was 2, instead of this, let's say we want 2 or more, okay? Which ones will this affect? Which ones will be different from what it matches up here? So with theater, it will catch the whole THE, right? And then Prometheus, it will catch ETHE. Okay? Oh, and of course, the. It also catches the word the, and it catches THE in theater. And then for Prometheus, it catches ETHE because those are all matching and it's 2 or more. Okay, so it's kind of this consecutive thing. Yes?
Can you add logical stuff? So like string match T, LKs, T, all that stuff.
So if I wanted to do capital T or little t, then I would have to break it up this way. I'd have to do capital T, little t, and say either match the capital T or the little t, and this. But then, oh, it gets complicated here. I would just match it. I would just do this. I would say, okay, either a capital T or a little t, okay, and then match either 2 or more of these things, okay, and then it will get that, okay. But if I broke this off, okay, then it will say either the capital T or little t, but only one of these, and then here, and immediately after the capital T or little t, we want 2 or more H or E's, okay. And so here we'll get this, but because of, so like in Prometheus, it's not going to catch the E because it says the first thing you have to find is going to be either a capital or a little t. Okay. When you are playing with regular expressions, there's a lot of trial and error, okay? Because you have an idea of how these things work, but then it's not until you actually try running the search command that you're like, oh, that is what I want, or that is not what I want, okay? I rarely get regular expressions exactly right on the first try, okay? So there's always kind of, you always want to do a few test cases and just say, oh yeah, this is matching the way I want it to be matching. Okay? So earlier we said, you know, you have match 0 or more with the star, okay? And then I showed you the dot, which is any character except the new line, right? And so you have, there's this kind of this super wild, which is dot star, okay? Dot star will be like match anything and everything, okay? Because dot is like any character, and then star is like 0 or more of these things. So dot star is, it'll match pretty much everything, and so here's this thing, okay? We have this, you can have greedy versus ungreedy matching, okay? And so greedy means like it's gonna go for everything that it can possibly gobble up, okay? So here we've got, you know, some HTML or XML code. And here I'm giving it find a div tag, and then anything between there, and then a closing div tag, okay? And so it's gonna find this div tag, and it's going to see this closing div tag, and it's also going to see this closing div tag, okay? And so generally it's going to go greedy, and it's going to try to get as much as it can get, okay? And so it gets the this one. Ungreedy says don't try to gobble everything. As soon as you find the closing div tag, just call it a day and say you found the match. And so you put the little question mark in there to make it ungreedy, and it closes it off there. Okay. So greedy matching will get the extra closing div, and ungreedy will not. So sometimes if you're using kind of these wilds with the the stars, you might want to play around whether you should use the question mark or not. Okay, and this is something like I have a hard time predicting if it's going to get too much or too little. So, okay. All right. We also have capture groups. Okay, and so in our text we can group together parts of a regular expression for capture. Okay. And we can use StringMatch and StringMatchAll. All right, and so here, this will say ABCD. Okay, so this has to match the text exactly ABCD, and it's going to capture the text BC. Okay, so these parentheses define what's called a capture group, and so here it will match just this thing, and of course we can put meta characters and things like that inside here. You give it the question colon, and it will say that's a non-capturing group. That's what we don't want to capture. Okay, and then and over here you can also have multiple capture groups. So here we'll capture ABC and we'll capture GHI. Oh, and this is not correct. It should be slash. Oh, I know it. I know it happened. It was using. You give it a /1 to a kind of 9, or even like /99, and you can do a back reference to that group you captured. Okay, so let me just okay, so we can run back references to the capture group. All right, so for example, and maybe this is better if I just do it in here. Okay. So here I've got the text A, B, C, D, E, F, G, H, I, J, K. Okay. So here the pattern is A with the capture A, B, C, D, and the capture group is around B, C. String extract will just find the pattern that matches it. Okay. String match makes note of the capture group, and it will say, okay, I found the matching text A, B, C, D, and you have defined this capture group, and so I've extracted that portion. It's going to extract out the text in the capture group here. All right. I can give it another pattern, A, B, C, G, H, I, and so it's got to match the exact string A, B, C, D, E, F, G, H, I. It's got to match this. It's got to find a match here, and then it's going to extract just what's in the parentheses. So this is our first capture group, ABC, and it pulls out the second capture group, GHI. Okay. All right. So here, let's say we're looking at like a web page or something, and like in the old days, you would italicize or bold text using I tags and B tags. Okay. And let's say you wanted to like update these things, so we're going to use emphasis tags. Now, this is a silly problem because I could just say like find and replace like this capital I tag and replace it with an emphasis tag. Okay, but I kind of want to show you how a capture group goes. Okay, like this is where it becomes useful. So here, this is the pattern that I want to match. Okay, I want to find this the less than sign. Okay. The less than sign is not a meta character, so it will match this literal thing. Okay. Then inside the less than and greater than, we want to find either the capital letter B or the capital letter I. Okay. I could also use a lowercase and lowercase I or whatever. But so this will match this part here, okay? And then I'm saying match anything that looks like a word, okay? So we're going to say /w for anything that's a word thing, and then the plus here means like multiple letters, right? Otherwise it would just match one letter. So here it says like one or more letters, so it's going to match the whole word emphasized, right? If you wanted, if you had two words in here, it would not match because the space would throw it off, okay? So if you wanted to match either word or space, you would have to put this in brackets, bracket /w space, and things like that, okay? So this would match the word emphasized, and that puts the word emphasized in the capture group. You guys see that? Okay, and then it says match the closing tag, okay? And then the / is not a meta character, so it'll match the literal / there also. Okay, so here, so if I do string match on the text, it says, oh, okay, based on the thing you gave me, I matched this part of the testing text, okay? And the capture group that I found was the word emphasized, okay? And if I gave it the other text string, text2, it will say, oh, here I found it over here with the B's, and then the capture group you gave me was emphasized, okay? And so, you know, this, if I changed exciting here, it will match, it will recognize that this is the capture group because it's inside the parentheses, okay? And so this is, here I'm going to use, yes, question?
Can you explain what the plus sign is?
So the plus sign is one or more, okay? So if I change the pattern, if I got rid of the pattern, if I got rid of the plus in the pattern, and let me just close this out, it will just match the E because it's only going to get one of these things here, okay? Okay, so it's going to say, it's looking at this thing, testing exciting text, because there's only a /w, it's just going to say, give me one character that's classified as a word character. Word character is any of the letters, any of the digits, or the underscore. Okay. So the pattern, we want to make sure the pattern has, oops, one or more, and then we're going to give it that there. Okay. So that will do that. If I change the thing to say exciting and happy, okay? Will this match using this pattern? It will not match because here I've got spaces, and spaces don't count as word things. So if I want it to match, I have to change my pattern to say give it any word thing or a space, and I just put a space in there, okay? And one or more of those. And so here now it matches exciting and happy because it's saying any letter and space and one or more of those things. Okay. And okay, so anyway, this is my capture group. Oops. So we're going back to the italicized, emphasized thing. So here I'm using, so this recognizes the capture group. In this case, the capture group being, what's being captured is emphasized. And here's a back reference. The /1 says, take whatever you found in that first capture group and put it here. So it's going to take emphasize and it's going to put it inside, or it's going to take the word emphasized and put it in between these M tags. Okay, and so here's our, you know, this was our original string. Here I've told it replace what you find in the pattern and then and take that word and put it in here. Same thing using the the other thing. It's finding what it matches, and then it's taking whatever's in the capture group and it's feeding it into this spot where I put the /1. Okay, so here's another example. Okay, I've got some phone numbers, some words here. Apple, and somebody typed in a phone number with spaces, typed in a phone number with dashes, and this person gave us 2 phone numbers. Okay, work with things, a semicolon, and then home, and then they put dots here. Okay, what a jerk, right? So now we have to we're gonna create this phone pattern, and so here we're saying, you know, a phone number, the first digit has to be not a 1, okay, or a 0. These are like the rules. So we say, okay, anything between a 2 through a 9, okay, and then 0 or 9, and we want 2 of those, and we put these in parentheses to say this is our first capture group, and then we want either a dash, a space, or a dot, okay, one of those characters, and then the digits 0 through 9, and we want 3 of those. Put that in a capture group, and then a dash, a space, or dot, and then we want 0 through 9 and 4 of those, and put that in a capture group. Okay, and so here when I tell it to run the extract, it's going to look for this, and it's going to just return the first thing that it finds. So it finds this one, it finds this as a match, and it finds the first number that it provided as a match. If I say extract all, it recognizes that there might be multiple matches in each of these strings. And so what it returns here, so here it returned a vector because it just returned 1 for each thing in there. When it returns, when you do extract all, it's going to return everything that it matches in each string, recognizing you could have multiple. So here, the first one, it doesn't return anything. Then it returns the first phone number, the second one, and then for the 4th element in our vector, it matches both of the phone numbers that appears here. Okay, but now it's returning a list. So that just complicates things a little bit, but it's pulling out all of the matching strings. Yes?
Wait, is there why you use 2, the true phone number between 2 to 9?
Yeah.
Why can't you just do the same?
I could have done 0 to 9, 3.
Yeah.
But if we want to be technical, as far as area codes go in the United States, there's no area code that starts with a 0 or 1, because those are reserved for the I'm making a long distance call identifier, which we don't really use anymore. We just type things into our thing. But back in the day, you would identify yourself as making a long distance call by typing in a 1, or an international call by typing in 011 or something like that. Now we have the plus character. String match will take these things. It will find the first match, so basically this, and then it pulls out the different matching groups. Okay, so the first one will be the area code. This will be the, I don't know what do we call this, and this will be the last 4 of the phone number, right? So that's what we have there. And then StringMatchAll does the same thing, except it will return it in list form because it recognizes that each thing in the vector of strings that you gave it could have multiple matches. So this will be StringMatchAll. And so in your homework 3, there's one portion where you're going to have to use regular expressions, because I'm telling you to go into this one column that keeps track of the manager records. And you're going to want to pull out each manager's record using regular expressions. And you'll probably have to use a match all, because sometimes in most seasons it will be one manager managing the whole season. But sometimes there will be a change of managers in the middle of the season. A manager is a coach, by the way. If you play baseball, the baseball coach is called a manager, okay? And so whoever is, managing the team, that might switch, and you might have 2 people listed in that text thing. So you're gonna have to use extract all or match all to pull out the parts that you want, and you'll want to pull out I think it's interesting enough. You're going to want to pull out the manager's name, the number of games he won, and the number of games he lost. Okay. Okay, and here are some more resources. There's a regular expression cheat sheet, Hadley's vignette on this, and then there's also some tutorials and things where you can test them out that are good. Okay, we'll